Hello, students. Let's start with the next session, which is the continuity to the asymmetric key cryptographic algorithms. Let us move to the second algorithm, which we are discussing about RSA cryptosystem. Already we have done with Diffie-Hellman key exchange algorithm, which is utilized to create a session key between the sender and the receiver, right? So RSA cryptosystem is developed by three inventors. The inventor name itself given as the algorithm name, that is RSA. RSA is reversed. RSA. R is reversed, S is Shamir, and A is Edelman. So the RSA cryptosystem is basically designed to create the key pair, that is public and private key combinations, and also it is utilized as a encryption and decryption algorithm too, right? So whereas Diffie-Hellman is the algorithm which is only utilized to create the session key, but not for the purpose of encryption and decryption, right? Whereas RSA has that capability to create the key pair, that is the public and private key combination, and also along with that we can do encryption and decryption procedure also. The key size may be dependent on the application which we are designing. So that starts from 512 bits to it may be 2048 bits, right? The procedure of the algorithm, let us see one after the other. Before that, for the encryption procedure, we are going to utilize this formula. This is to generate the ciphertext in the encryption algorithm, right? So we are going to design with the encryption algorithm first of all. Then we are going to with the decryption procedure, right? So in the encryption procedure, we are going to deal with the plain text M, and we are going to have, we must have E and N here to encode this plain text, right? And we must have D and N to decode ciphertext back to the plain text message M. Okay, so this is the basic thing which we have to remember in our brain while we are about to design our RSA crypto system, right? The algorithm is as follows. See, we have to select, okay, we have to select two prime numbers P and Q. We have to select two prime numbers P and Q, right? This here we are mentioning large prime numbers, so we can go with the large prime numbers also. Cost wise, it will be very, cost wise, it is somewhat we have to do expense on this RSS system, but for generation of the key pair combination and for the encryption decryption process, it is very standard algorithm, right? Now, N is created or computed with the formula P into Q, right? N equal to P into Q. So whatever the prime numbers we select, just the product of these two will be our N value. Then next, we are going to find Z, which is prime number 1 minus prime number 2. Then whatever the result we get, we are going to apply multiplication. So whatever the result we get, we are going to save in Z. So this Z is utilized to find E value. So that is the reason we are going to find this Z value, right? N is also called as pi of N. Okay. Now choose number E. Okay, as we have discussed in the encryption, we need E comma N, and in the decryption procedure, I need D comma N. So for finding N, we are directly created with the multiplication of two prime numbers chosen, right? Now, the procedure to find E needs Z. See, choose E less than Z. See, N less than N. So, product of two prime numbers. So, whatever the result we get, so dependent on that value, we have to choose E, where E must be less than N. Okay? Don't forget, E must be less than N. At the same time, which has no common factor with Z. Okay? So we have to, if I have chosen 4, Okay, if I have chosen 4, then I have to think in such a way that there is no common factor for Z and 4. Okay, let us go with Z as 27, right? So 27 and 4 are not having common factor, right? Yes. So for that, I can go with E as 4. Got this, I guess. So there should be no common factor for the generated Z and also our chosen E. Okay, so that is a condition to choose E. Next, find D where E into D minus 1 should be divisible by my Z value. Okay, is exactly divisible by my Z value. See, that is the reason I need Z to find. Okay, so because E and Z are, E and D are dependent on Z value, where E and Z should not have a common factor, where D and Z combination of ED minus 1, this expression should be divisible by Z. So that is a next point when we are choosing Z. Okay. So let us see all this in one example. Don't worry about it. So after finding our E and D, my public key generated for encryption procedure is E comma N or N comma E. We can write anyways, right? Similarly, my private key is N comma D and D comma N. Okay. Now, after getting my public and private key combination, I'm going to apply my encryption procedure, which needs E comma N, that is my public key. See, here I'm utilizing public key. Don't forget, in RSA Cryptosystem, encryption procedure is done with respect to E comma N, where E comma N is a public key, right? Where M is a message, plain text message. N is the product of two prime numbers. Got this, I guess, right? Next, after encryption, we need to get our plain text back, right? So for that, we have to apply private key. Okay, we have to apply private key, that is D comma N on the ciphertext with respect to my pi value N, that is product of prime numbers, to get my ciphertext to decoded into the plain text. Okay. So here the public key is shared and private key is always hidden with that particular user itself. No other user knows the confidential key of private key. Only that particular user will be maintained confidentially with the private key, whereas all the public keys will be shared, right? So let us see one example so that you will be having a good understanding about it. Okay. See here, choose P and Q. So I have chosen 5 and 7. Now find N value where N is P into Q, right? So P into Q, 5 into 7 is 35. Now I have to find my Z value. Z I can get by P minus 1 into Q minus 1. So 5 minus 1 into 7 minus 1, that is 4 into 6. My Z is 24. Now I have to find E such that E and Z should not have a common factor. Yes. So do 5 and 24 have any common factor? No, right? So I can choose E as 5. Got this. Next, D as 29, where E into D minus 1 and my Z, this should be exactly divisible by my Z. So if you find 29 into 5 value minus 1, that will be exactly divisible by 24. So this is the condition to choose D. See, after these 4 steps, we are generated with the keys, that is public key as N comma E, that is 35 comma 5. Next, private key as N comma D, that is 35 and 29. Okay. See, after this, I'm going to encrypt the data. The word plain text which I have utilized is LOOV. Using this, I'm going to encrypt my data. Now, alphabetical order, I'm assuming A as 1 and Z as 26, right? Now, LOVE is my plain text. L, I'm representing with the numeric representation 12, okay? O as 15, see alphabetical order, just alphabetical order. After that, whatever the value I get here, this value to the power of E. So what is my E here? 5, right? So this is nothing but 12 to the power of 5. Similarly, this is 15 to the power of 5. This is 22 to the power of 5 and 5 to the power of 5. Okay. So after getting so and so results, I'm going to apply my mod n to these values. See, after applying mod n, I am getting the values as 17, 15, 22 and 10. In my alphabetical sequence order, 17 is Q, O, V, J. So for the plain text LOE, I got the ciphertext as QOVJ. Okay, this is my ciphertext. All this procedure is done at encryption side itself, right? Now we are moving for the decryption procedure. So decryption is nothing but take those 17, 15, 22 and 10, whatever we got. Then you apply with your private key, that is D, N. C to the power of D means 17 to the power of 29. 15 to the power of 29, 22 to the power of 29, 10 to the power of 29. After applying this, whatever the value we are getting, just mod n. So my n value is 35, right? So after applying those values, I am getting some values, right? So these values are again 12 in the alphabetical order is L, 15 is O, 22 is V, 5 is E, right? So I got my plain text back, whatever the user has sent, sender has sent, the receiver has received the ciphertext and he has decrypted with C to the power of D mod N concept with the private key D, N, so that our plain text is back. So this is the exact working function of RSA system, where when we are encrypting with one public key, we need its private key combination to decrypt that for sure, right? So this is the exact advantage of RSA crypto system. See, the RSA crypto system is very strong in nature, but obviously when there is a good thing, we'll be facing a number of attacks also at the same time. So the only 4 attacks where RSA crypto system will be facing are these 4. Brute force, where brute force will be applied to all the combinations of the private keys. See, keep on applying all the private key possibilities, that is a brute force. Mathematical attack is with respect to the finding your P and Q values. I mean, whatever the prime numbers we have chosen. So these attackers will be concentrating on which factors you have chosen this P and Qs. Timing attacks are dependent on the decryption algorithm side. Okay. So this is how much time you took to decrypt your data. So all these running functionalities will be known in the timing attacks. Whereas chosen ciphertext attack is exploited with the properties of the RSA crypto system. See, RSA crypto system has a number of properties where we are going to generate public and private key combinations. So for that, what is the procedure we followed? Everything, every property of a RSA crypto system will be known by this chosen ciphertext attack. Okay. So if you have any doubts regarding this RSA crypto system, feel free to contact either in the college or through comments. Thank you for listening.